Hello everyone, this is Deepak Yadav, your physics teacher. I welcome you all in the new academic session of class 11th in Sarda Global School. You are in the fabulous environment of class 11th, and today our objective is to learn about the origin and introduction of physics. Before starting all the chapters consisting in the syllabus, today we will go through the introduction and origination of the word physics. We will define the subject and we will establish its relationship with mathematics also. We will learn some mathematical tools which will be quite helpful in our future calculations. Physics is a wonderful world and a wonderful subject. The word physics originates from a Greek word which means nature. Nature means prakriti. Everything that we see around us is a part of that nature. Sanskrit equivalent of physics is bhautiki, which means physical world. That also signifies nature. Let's define physics. Physics is the branch of science that deals with the study of basic laws governing the nature and their manifestation in various natural phenomena. Since we know that in our surroundings there are various phenomena that occur in nature and they are governed by some laws of physics, and whatever laws we study in physics, they all are applicable and visible in our natural surroundings. That's why we define physics as the branch of science that deals with the nature and natural phenomena. Learning physics requires mathematical knowledge to establish the empirical laws of nature. Since laws of nature cannot be established in few words only, they are associated with some mathematical calculations and interrelationship between the different variables that are often used. Mathematical formulae can be applied to define how physical objects interact and the kind of relationships among them. Dear students, this is quite necessary for you to understand the interrelationship between mathematics and physics. You know, mathematics is independent of physics, but physics is not independent of mathematics. It is being said that physics is the king of science while mathematics is the queen. This makes us quite helpful in study the basics of physics. Mathematics helps in further calculations. So let's proceed with some mathematical tools that are helpful in the further study of physics. In future, we will know about the importance of mathematics in the context of physics. Each and every derivations and calculations are inseparable of mathematics. So you need to know the basic concepts of mathematics to study the physics far effectively. It's very important to learn these tools and also the skills to apply them wherever required. Knowledge of mathematics is not everything. You must know about the skill wherever you should apply all these techniques and tools in physics. Let's begin with algebraic identities. These identities, we have seen these identities in class 7th, 8th, 9th and 10th, and we have also applied these in solving mathematics. All of these identities are very useful in learning physics. First is a plus b whole square equals to a square plus b square plus 2ab. Next one is a minus b whole square equals to a square plus b square minus 2ab. Next one is a square minus b square equals to a plus b, a minus b. This is the factorization formula often used in mathematics. Next one is a square plus b square equals to a plus b whole square minus 2ab, or in another form we can write a minus b whole square plus 2ab. Next one is a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Next one is a plus b whole square plus a minus b whole square equals to 2 under bracket a square plus b square. A plus b whole square minus a minus b whole square equals to 4ab. Next one is a cube plus b cube equals to a plus b whole cube minus 3ab into a plus b. In another form, a cube minus b cube can be written as a plus b into a square minus ab plus b square. This is factorization formula for a cube plus b cube we often use. Next one is a cube minus b cube equals to a minus b whole cube plus 3ab into a minus b. In another form, the formula is used for factorization. A cube minus b cube equals to a minus b into a square plus ab plus b square. Next one is a plus b whole cube. A plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. In another form, this can be written as a plus b whole cube equals to a cube plus b cube plus 3ab under bracket a plus b. This comes by taking the terms common from the middle two terms, 3ab into a plus b. Next one is a minus b whole cube. A minus b whole cube equals to a cube minus 3a square b plus 3ab square minus b cube equals to, again in another form, a minus b whole cube equals to a cube minus b cube minus 3ab into a minus b. I expect all of you to remember all these algebraic identities so that you can use it in further study of physics in future classes. Next we will proceed with quadratic equation. All of you have studied this part in your mathematics. This is the basic of mathematics, and we should have the knowledge about it. This is often used in calculations and solving the numericals in physics. You know, the standard form of the quadratic equation is ax square plus bx plus c equals to 0, where a not equals to 0. An equation of second degree is called a quadratic equation. It has degree 2. The maximum power of the variable x is known as the degree of the equation. Hence, its degree is 2, because the maximum power of x is 2. Now, a not equals to 0. Why is this condition necessary? If a becomes 0, the term x square will be vanished, and this will not be a quadratic equation so far. Hence, the constant a may never be 0. The constants b and c can be 0. Such equations have two roots or solutions or values for x. They are sometimes called zeros, say alpha and beta. These are given by a quadratic formula. X is equals to minus b plus minus root under d divided by 2a. X is equals to minus b plus minus square root of d divided by 2a, where d is equals to b square minus 4ac, called the discriminant of the quadratic equation. The solutions for x are called roots, and the nature of roots or the existence of roots completely depends upon the value of the discriminant. Please note these facts. If d greater than 0, then real roots exist, and these two roots are unequal. That means alpha not equals to beta, while alpha and beta are real values. Second condition is that d equals to 0 if discriminant, that is the value of b square minus 4ac, calculated from above equation, b square minus 4ac equals to 0, that means d equals to 0, then real and equal roots exist, and in that case alpha equals to beta equals to minus b by a. Because if you substitute d equals to 0 in above equation, d equals to 0 here, if you substitute d equals to 0, then you will get x is equals to minus b by a. That means both values of the equation comes out to be minus b by a, 2a. That means alpha equals to beta equals to minus b by 2a. The next condition is if d less than 0. If discriminant less than 0, roots are imaginary, that means they are not real, and in general case they are not need to be calculated. A very important relationship between the roots and the coefficients of quadratic equation. This part of mathematics is being taught in class 10th under the section quadratic equation, and it is the important relationship. If ax square plus bx plus c equals to 0 has roots alpha and beta, since it is a second degree equation, so there are two roots alpha and beta. These are the values of x which are named as alpha and beta. Then the relationship between the zeros alpha and beta and the coefficients a, b and c is given by sum of roots that is alpha plus beta is equals to minus b by a equals to minus coefficient of x divided by coefficient of x square. Since our standard equation is ax square plus bx plus c equals to 0, the coefficient of x square is a, coefficient of x is b and the constant term is c. Hence, the sum of roots alpha plus beta comes out to be minus b by a, that means minus of coefficient of x divided by coefficient of x square. And the product of roots, that means alpha into beta, is equals to c by a equals to constant term divided by coefficient of x square. Dear students, I expect all of you have understood whatever I have taught to you under this section. This is quadratic equation and most of you are quite familiar with this section as you have studied it in class 10th. Now let's proceed with a question of quadratic equation. You have to solve the equation 6x square minus 13x plus 6 equals to 0. We will use here quadratic equation to solve this question of quadratic equation. The question is 6x square minus 13x plus 6 equals to 0. Here, if we compare the given equation with the standard form, this equation is compared with this x square plus bx plus c equals to 0. It is clearly visible that a equals to 6, b equals to minus 13 and c equals to 6. a equals to 6, b equals to minus 13 and c equals to 6. So, calculating the value of discriminant d equals to b square minus 4ac. If you substitute all this value, b equals to minus 13, a equals to 6 and c equals to 6, you will get the value of d is 25. The value of d comes out to be 25, whose square root is 5. Square root is 5. Since d is greater than 0, then according to the condition, the nature of roots are real and unequal. There will be existence of real roots and both the roots alpha and beta will be unequal. Proceeding further, x is equals to minus b plus minus root d by 2a. This is quadratic formula. This is important quadratic formula. We have seen it earlier. X is equals to minus b plus minus root under d divided by 2a. Since we have real and unequal roots and the value of d is 25, whose under root is 5, so substituting all the values, we will get 18 by 12 or 8 by 12. 18 by 12 or 8 by 12. The two values comes out to be 18 by 12 or 8 by 12 as alpha and beta. On further simplification, we get x is equals to 3 by 2 or 2 by 3 in simplest form. This is the solution of the given quadratic equation. And quadratic equation is also a very important part of mathematics that is usually used in physics for solving numericals in different cases and for deriving and in derivations in different chapters. Next, we will proceed with binomial theorem, an important topic which is often used in physics. Binomial theorem. Binomial means two terms. Binomial means two terms. Binomial theorem states that if n is any integer, may be positive or negative, or a fraction, n may be integer or a fraction, and x is any real number, then 1 plus x whole to the power n gives this expression, can be written as 1 plus x whole to the power n equals to 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube plus and so on. Here a new term comes for you. It has been used. We have used 2 factorial and 3 factorial. Further it comes 4 factorial, 5 factorial, 6 factorial are used. 2 factorial means 2 into 1. 3 factorial means 3 into 2 into 1. 4 factorial means, similarly 4 factorial means 4 into 3 into 2 into 1, 1 and so on. In general you can write a factorial n equals to n into n minus 1 into n minus 2 into 3 into 2 into 1. You should multiply in decreasing order and the final term will be 1. If mod x less than very less than 1, if the mod x is very less than 1, then the above binomial theorem reduces to 1 plus x whole to the power n equals to 1 plus nx. This condition is often used in physics. This condition is used in the chapter gravitation. We will apply it for the calculation of acceleration due to gravity at some altitude or depth. That means we have seen the binomial theorem which gets reduced to 1 plus x to the power n, 1 plus x whole to the power n equals to 1 plus nx under the condition mod x is very less than 1. This is the binomial theorem. This is the binomial theorem we have seen, and this will be applied further in physics. Its reduced form, that when mod x is very less than 1, then the value of 1 plus x whole to the power n comes out to be 1 plus nx. This is very important result we will use. Let's see how we can apply this theorem in physics. How will we apply it in physics? We will see with an example. Let's see a question. The acceleration due to gravity at a height h above the surface of the earth, assume radius equals to r, is given by z dash equals to gr square upon r plus h whole square. If h is very less than r, then show that g dash equals to g under bracket 1 minus 2h by r. Again I am repeating the question. The acceleration due to gravity at a height h above the surface of the earth, assume the radius of the earth to be capital R, as earth is spherical in shape. You have to assume it in this question. is given by g dash equals to gr square upon r plus h whole square. The condition has been given that the height h is very less than the radius of earth. Height h is very less than the radius of the earth. Then we have to reduce this expression to the final result, that means g dash equals to g under bracket 1 minus 2h upon r. We will reach to the final result from the above given expression using the binomial theorem. Let's see. Since the given expression of acceleration due to gravity at altitude h is g dash is equals to gr square plus r plus h whole square, h being very small than the radius of the earth, we have to show that g dash equals to g under bracket 1 minus 2h upon r. Clearly these two equations must be equivalent to each other, but there is difference in the right hand side. But the above equation is reducible in the form g into 1 minus 2h by r. The RHS part will be reduced to g into 1 minus 2h by r when we will use binomial theorem. Let's see the proof. Since g dash equals to gr square divided by r plus h whole square, let's take r common from the denominator. You will get gr square divided by r under bracket 1 plus h by r whole to the power 2. Proceeding further, distributing the power in the denominator, gr square divided by r square under bracket 1 plus h by r whole square. The term r square in the numerator and denominator will be cancelled out, and we will get g dash is equals to g into 1 plus h by r whole to the power minus 2. You will take the numerator above denominator at the numerator side. You will get the power will take its negative form, and the expression will come out to be g dash is equals to g under bracket 1 plus h by r to the power minus 2. Now we will use the condition of binomial theorem. As we have seen that 1 plus x whole to the power n equals to 1 plus nx under the condition mod x is less than 1. Here on the right hand side, the term 1 plus h by r whole to the power minus 2, h by r, the value of h by r is very less than 1. It has been given in the question, it has been provided in the question, we have seen it earlier. Please see on at the question I have provided you. The condition h upon r is very less than 1. It has been given, hence we can apply the condition of special condition in the binomial theorem, that 1 plus x whole to the power n, 1 plus x whole to the power n is equals to 1 plus x whole to the power n is equals to 1 plus nx, as the value of h by r is very less than 1. That is, the value of mod x is less than 1. That's why we are using this formula here. So proceeding further, this equation reduces to g dash is equals to g into 1 plus minus 2 into h upon r. Hence we get the final expression g dash is equals to g into 1 minus 2h by r. This shows the variation of acceleration due to gravity with the height of the object above the earth's surface. Hence the expression is proved. We have seen the use of binomial theorem in solving the calculations, solving the problems in physics, how the different expressions are reducible to its simplest form when we use mathematical tools. Let's see a very important part, trigonometry. Dear students, you are familiar with this section, trigonometry. This section has also been taught in class 10th. You have seen it in class 10th. Trigonometry basically comprises the study of right angled triangle and its angles and sides and their correlations. Under this section, we will begin with systems of measurement of an angle. Dear students, basically we use two systems of measurements of angle. One is degree measure and another is radian measure. The degree measure is used in sexagesimal system. This system is known as sexagesimal system. In this system, the unit is degree, and in this system one right angle, you know right angle, this is 90 degree. The angle equivalent to 90 degree is called right angle, and 1 degree is equals to 60 minute. This can be written as this, and 1 minute is equals to 60 seconds, written like this. In circular system of measurement of angle, the unit of angle is radian. Since we know a very important mathematical relation, theta is equals to arc upon radius equals to L by R. Here theta is in radian. The value of theta comes out to be in radian. This should be in radian. L and R must have same units. So let's define 1 radian. Looking at the above expression, it is quite clear that when L equals to R, the value of theta will come out to be 1 radian. So the definition of 1 radian is the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. That means 1 radian is the angle subtended by an arc which is equal to the radius of the circle. Arc is equals to radius. L equals to R. That means theta is equals to 1 radian. Theta is equals to 1 radian. This is important definition. Now, one noticeable point is here. Establish the relation between the radian and degree measure of an angle. Establish the relation between the radian and degree measure of an angle, or prove the relation pi radian equals to 180 degree. Let's see the proof. As we know that a complete circle subtends the angle equals to 360 degree at the center. Complete circle subtends 360 at the center, and in that case the arc length will be equals to the circumference, which will be 2 pi r, and the central angle will found to be 360 degree. If we substitute all these values in the above expression, theta is equals to L by R. It is quite clear that the expression will reduce to 360 degree equals to 2 pi r upon r radians. On simplification, it comes out to be 2 pi radian equals to 360 degree, which gives pi radian equals to 180 degree. And thus an important relationship between radian and degree measure of angle is established, that is pi radian equals to 180 degree. Next we will proceed with trigonometrical ratios. Let's consider a right angle triangle ABC in which angle B is 90 degree. Obviously angle C and angle A will be acute angles. If we consider angle C equals to theta, then the side opposite to angle C is considered as perpendicular and the side BC will be the base, and the side opposite to the right angle is the largest side, which is called hypotenuse. You all are familiar with this section. You have studied it in class 10th under the section trigonometry. So you must know the variation of perpendicular and base with the angles. If we consider angle A, then the perpendicular will be BC and AB will be the base. Hypotenuse is inconvertible. This will not be changed. Base and perpendicular are interchangeable with the angles you are considering while solving the mathematics. Now angle A and angle C are acute angles, and if we are considering angle C as theta, then corresponding to each acute angle there will be 6 trigonometric ratios. These are sin theta equals to perpendicular by hypotenuse, cos theta equals to base by hypotenuse, tan theta is equals to perpendicular by base, sin theta equals to perpendicular by hypotenuse, cos theta is equals to base by hypotenuse, tan theta equals to perpendicular by base, cosec theta is equals to hypotenuse by perpendicular, sec theta is equals to hypotenuse by base, cot theta is equals to base by perpendicular. And you must know sin theta and cosec theta are reciprocal, cos theta and sec theta are reciprocal, tan theta and cot theta are reciprocal of each other, hence their multiplication is equals to 1. Now we must be familiar with the fundamental trigonometric identities. Since cosec theta and sin theta are reciprocal of each other, sec theta and cos theta are reciprocal, cot theta and tan theta are reciprocal, so their product is 1. Now tan theta is the ratio of sin theta and cos theta, and cot theta is ratio of cos theta and sin theta. This is also very important identities. Next, sin square theta plus cos square theta equals to 1. 1 plus tan square theta equals to sec square theta, and 1 plus cot square theta is equals to cosec square theta. Again I am repeating, since the cosec theta and sin theta are reciprocal of each other, so their product is 1. Sec theta and cosec theta are reciprocal of each other, so their product is 1. Cot theta and tan theta are reciprocal of each other, so their product is 1. Tan theta is equals to sin theta upon cos theta, it is the ratio of sin theta and cos theta. Cot theta is equals to cos theta upon sin theta, it is the ratio of cos theta and sin theta. Next identities are sin square theta plus cos square theta equals to 1. 1 plus tan square theta equals to sec square theta. 1 plus cot square theta equals to cosec square theta. Dear students, you have to remember all these identities fluently, and I am quite sure this will be proved far helpful in your future study of physics, in the study of all the chapters that are contained in your syllabus. Next we will start some important trigonometrical formulae. You have to remember all these identities. You must remember, because these are very important. Without these identities and without these mathematical tools, you will be quite unable to understand all the basic concepts and fundamentals of physics. You cannot imagine the study of physics without these mathematical tools. Again, I am repeating, physics is the king of science and mathematics is the queen. So, it is very necessary for you to learn all these formulae and identities. Let's see. Sin A plus B equals to sin A cos B plus cos A sin B. Sin A plus B equals to sin A cos B plus cos A sin B. Sin A minus B equals to sin A cos B minus cos A sin B. There is the difference in sign only. The expressions are same. You have to visualize it carefully. Next one is cos A plus B equals to cos A cos B minus sin A sin B, and cos A minus B equals to cos A cos B plus sin A sin B. Here you should notice that whenever there is plus here, there is minus, and for minus here is plus. And you have to remember cos cos sin sin, cos cos sin sin. In this way you can remember these identities. Next one is tan A plus B is equals to tan A plus tan B, tan A plus tan B divided by 1 minus tan A tan B. Tan A plus B is equals to tan A plus tan B divided by 1 minus tan A tan B. Next one is tan A minus B is equals to tan A minus tan B, tan A minus tan B. Look here, here is minus, here is minus, here is plus, and the opposite sign is in the denominator. So you must take care while learning this. You can remember it easily. These identities are very important. So look carefully. Tan A minus B equals to tan A minus tan B divided by 1 plus tan A tan B. And tan A plus B equals to tan A plus tan B. Whenever there is plus, here is plus. There is minus, here is minus. In the denominator, opposite sign is there. Now, tan A minus B equals to tan A minus tan B divided by 1 plus tan A tan B. Proceeding further, sin 2A. This is the multiple of angle 2A, 3A, 4A. Sin 2A. If you see carefully, you have seen sin A plus B here. You have seen sin A plus B. If you put B equals to A here, B equals to A here on both sides, that is in the LHS and RHS both, you will get the expression 2 sin A cos A, 2 sin A cos A. Sin 2A equals to 2 sin A cos A. And the tan formula for sin 2A is 2 tan A divided by 1 plus tan square A. 2 tan A divided by 1 plus tan square A. Cos 2A is cos square A minus sin square A. Cos square A minus sin square A. Similarly, again, if you put B equals to A in the expression cos A plus B above, cos A plus B above, that means here if you put B equals to A on both sides, then on simplifying you will get the expression cos 2a equals to cos square a minus sin square a, and on substituting cos square a with 1 minus sin square a, you will get 1 minus 2 sin square a, and again substituting sin square with 1 minus cos square a, you will get 2 cos square a minus 1, and the tan formula is 1 minus tan square a divided by 1 plus tan square a. The tan formula for cos 2a is cos 2a equals to 1 minus tan square a divided by 1 plus tan square a. For sin 2a, this is 2 tan a divided by 1 plus tan square a, and on dividing both of these expressions, you will get tan 2a equals to 2 tan a divided by 1 minus tan square a. Tan 2a equals to 2 tan a divided by 1 minus tan square a. Dear students, I am trying to make these identities easier for you to learn, because these are very important. Sin 2a, how did it come? If you put b equals to a in the expression sin a plus b, you will get 2 sin a cos a. In the expression b cos a plus b, if you put b equals to a, then you will get cos square a minus sin square a, which is further reducible to 1 minus 2 sin square a and 2 cos square a minus 1, and the tan formula for sin 2a is 2 tan a divided by 1 plus tan square a, and the tan formula for cos 2a is 1 minus tan square a divided by 1 plus tan square a, and dividing both of these equations, we will get tan 2a equals to 2 tan a divided by 1 minus 2 tan a divided by 1 minus tan square a. Next, if we add the above two equations, sin a plus b plus sin a minus b, we will get on simplification 2 sin a cos b, 2 sin a cos b, 2 sin a cos b. Sin a plus b plus sin a minus b is 2 sin a cos b. And in case of difference, you have to only exchange sign with cos. In case of difference between sin a plus b minus sin a minus b, you have to exchange sign with cos. Next, cos a plus b, third and fourth equations, identities, when we add them, cos a plus b plus cos a minus b, cos a plus b minus plus cos a minus b, the above two equations, these two equations, when we add these two equations, then this term will cancel out and the result will be 2 cos a cos b. The result will be 2 cos a cos b. This one, it's clear? 2 cos a cos b. And if you take the difference of those two expressions, the result finally comes on simplification minus 2 sin a sin b. Proceeding further, sin c plus sin d is equals to 2 sin c plus d by 2 cos c minus d by 2. Sin c minus sin d is equals to 2 cos c plus d by 2 sin c minus d by 2. Cos c plus cos d equals to 2 cos c plus d upon 2 cos c minus d by 2. And cos c minus cos d equals to minus 2 sin c plus d by 2 sin c minus 2 d by 2. Dear students, look here. Whenever there is sin plus sin, here is sin cos, and in case of difference you have to reverse cos with sin. In case of cos, sum of cos c plus cos t, here cos is used, and in case of difference sin is used. In case of cos, sum of cos plus cos, you have to write cos plus cos, and in case of difference cos c minus cos t, you have to use sin 2 sin minus 2 sin c plus t by 2 sin c minus t by 2. You have to use minus here. This comes out with the above, using the above identities, and thus we have seen different mathematical tools which are quite useful to us, and this is the today we are stopping the topic here. This was our first class. I expect you all enjoyed it well. We will meet in the further class with some more mathematical tools in physics, which will be proved far helpful in the study of physics in future classes. Okay.